Start recording. Okay, good. So it's recording and I have Paint open up. So my binary for my first letter is N. So that number is 0, 1, 0, 0. And then this part here, 3 ones and 0. Right? Let me just double check that. Okay. So if I wanted to blink this, right? In terms of LED, I'd have 8 LEDs out, right? So 1 LED, 2 LED, 3, 4, and then 4 more for this side. And these ones would be shut off, right? The ones with zeros would be shut off. And this one would be on, right? These 4 would be on, right? So first, I need to set up the circuit. So I'd have to visualize the circuit. So I'd get my Arduino board. I'd say, okay, I'm blinking LEDs, right? I need some digital pins. How many of them I got? Well, I got 13 here. So let me just use 1 to 8. So pins 1 to 8. I'm gonna connect up LEDs, same way, resistor, LED, ground, right? Resistor, LED, ground. Same way, like that we did the blink circuit, right? Instead of going from pin 13 to the resistor to the LED to ground, we go from pin 1 to 1 LED, pin 2 to 1 LED, and so on and so forth. And we can connect all the grounds up together and put them back in the ground. Simple electronic setup, right? Good. Now we have the circuit kind of built. What does the code for this look like? Well, I wrote a program before. So the first thing I need to do is, how do I get that ASCII number into my computer program? Well, for Boolean numbers or true and false, high and low, data type, we use the bool data type, BOL. It's short for the Boolean data type and has 2 values, false and true, which we know translates to high and low or on and off, right? So to get that number in, we can just create a variable bool, ASCII, n, right? And put those values in. Now notice that this variable is an array. So as you guys said, you did MATLAB, so you know what an array is. So instead of some variable x, like int x, right, being equal to one number 6, we can do int x and we use square brackets to indicate that this here is an array of integers holding multiple numbers. So some like 6, 7, 8, 9. So that's the same thing we do for the Boolean number, right? We do bool, right? And then we do some ASCII, some variable name. Let's just call it var. Var, V, A, R. And we can set this to true. And that there stores the value true, right? Or alternatively, we can set it to false. False. And it stores the value false. Now, if we do an array of Boolean variables, we can store multiple true and falses, right? So we can do bool, var, and then we open square bracket, close square bracket. And then we use this notation, which I'll discuss, and you guys will learn it over time. And we can store multiple falses and trues, multiple Boolean states, right? The same way we would do it with an integer, the same way you would do it in MATLAB. In MATLAB, you can just as easily say x is equal to, and you would use square brackets in MATLAB, right? In C, we use the square brackets on this side, right? In MATLAB, use x is equal to square bracket 6 space 2 space or a comma space 3, and then you can put a semicolon for another row in MATLAB, right? You guys remember that stuff. So it's similar in C, right? Maybe some slight differences, but the concept is the same. So that's what I created here. A Boolean array. Let's see if I can make that big. And I name it ASCII n, which is just the name that I want to give it. And I give it that ASCII value for my name, right? False, true, false, false. right? False, false, true, false, false. And then true, 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 false, right? Back here, true, 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 false. So that's the number in there. And I can do operations on it, right? Yeah. So I have the number stored in. I need to set up my Blink program, right? So remember two things from the Blink program, two things. Let's create some more space. The two things you remember are pin mode, right? And then we open parentheses, we say pin 13, and then we say output. And this here is in your void setup, right? And then in your void loop, that's where we're at. We do digital write, right? 13, comma, high. Right? You guys remember this? These two commands. So how many pins are we using? Let's go back to the circuit diagram. Here, we're using 8 LEDs and we're connecting them up to 8 pins, right? 8 pins. So therefore, we need to set pin 1, 2, 3, 4, 5, 6, 7, 8 as outputs. So back to our code. So in order to do this, we would need to write pin mode, pin 1, comma, output, right? Semicolon. Next line, pin mode again. Pin mode 2 for pin 2, comma, set that as an output as well. And then do pin 3, right? Then do pin 4, then do pin 5, then pin 6, then do pin 7, then do pin 8. But that's a lot of typing, right? So now we introduce a for loop, right? So again, from your previous programming experience with MATLAB, you know what a for loop is, or you know what a loop is. So a loop is a way that we can execute some code, right? Continuously, right? Execute that same code over and over and over again, right? Based on maybe some set value like 4 times or 5 times or 6 times. Okay, good. How do we do that in C? Well, we use this syntax. So 2 syntaxes, the array syntax, int, the variable name, then we do square brackets, and that's equal to open curly bracket, right? 1 variable, 2 variable, 3 variable, close curly brackets, and always end with semicolon, right? And C. For a loop, we do for a loop. There are other loops. There's the while and do while loop, which I covered last class very briefly. We do for, and then we open some parentheses, right? Good. Then in here, we're going to put some condition. And if this condition is true, right, then we're going to execute curly brackets again, some code, okay? Some code based on whether or not this condition is true, right? And that's it. That's all there is to the for loop. Now, you might notice that there are a few things inside the for loop. Now, because I want to execute pin mode, right? Pin mode for pins 1, 2, 3, 4, 5, 6, 7, 8. Inside my for loop, I have that command, pin mode, and I have a variable I. Now, this variable is going to change from 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8. How I do that is first I set up a variable I, which outside, so that it's a universal variable, which is scope, a scope thing. And maybe we might cover this later as well, right? Different scopes. Okay, so I set up this variable I, int I, and I use it as a condition for my for loop. So for I is equal to 1, comma, I less than 9, I plus plus. What does that mean though? Right? So first I is equal to 1, comma, I less than 9, I plus plus, right? Plus plus. What this is saying is start the value of I from 1. Start value of I from 1. So I is equal to 1. Then, if I is less than 9, execute this code, right? This is the condition. Condition. This here is, we can call this like a starter value or something like that. So I less than 9. As long as I is less than 9, execute some code. Then after you finish executing the code, increment. Increment I by 1. Increment. Now remember I talked about this. I talked about I plus plus, right? Saying that I plus plus, if the value of I was 3, right? It adds 1 to that, the plus plus. That's what that means, increment, right? Good. So essentially what's going to happen is going to first say, okay, I is equal to 1. Great. I is less than 9. 1 is less than 9. 1 is less than 9, right? 1 less than 9. True. Execute this code. After this code is finishing, increment I to 2. Is 2 less than 9? Great. Execute this code. Increment. Execute this code. Increment. Execute this code. Increment. Execute increment. 8. Right? 8. It's 8 less than 9. Great. Execute this code. Increment. 9. Is 9 less than 9? No. Don't execute this code anymore. Move on to the next set of commands. And that's what we did here. Right? Void setup, pin mode output for I equal 1, I less than 9, I plus plus. And this value is going to change from 1 to 2 to 3 to 4, right? To 5 to 6 to 7 to 8, right? And we didn't have to type all that crap out, right? We just typed these 2 lines, right? For that and pin mode that instead of typing out 8 lines, which is pretty efficient. Next, we want to do 2 things. We want to turn the lights on, so digital right, high. I want to turn the lights off, digital right, low, which we know. And of course, we want delay in between, delay 1000 milliseconds, which is 1 second, 1 second in between. All right, good. Now, remember, it's a binary number. This ASCII number is a binary number. The ASCII number is a binary number. You guys are still seeing my screen, right?
No, sir.
Oh, sir.
It just came off. All right. Well,
Yes, sir.
you were seeing all the time though.
Yeah.
Yes, sir.
Okay, I'm back now.
All right, good. Okay, good. Yeah, so remember this ASCII number is a binary number, right? It was 0, 1, 0, 0, 1, 1, 1, 0, right? This is N in ASCII. And you guys are going to do the letters of your name, right? So that everybody's doing different thing. Let me just plug in my battery. Okay. So for this, we want some lights to be on, right? I want some lights to be off, right? So within the digital right high, so digital right high, right? Of course, you have the pin number here, right? So digital right high, we're gonna do another digital right low, and we're gonna have a delay in between here, right? Delay. Just let me just write that in, right? And delay here, right? Now we want to turn it on and then we want to turn the lights on and we want to turn the lights off. But we don't want to turn all the lights on, right? But all of them we do want to turn off, right? Good. So what we need to do is use that same for loop, right? Let's say we wanted to turn all the lights on again. We would use that same for loop. So we'd use for I equal to, right? 1 digital write high, right? For I less than 9 digital write high. And we do the increment, of course, right? I plus plus, right? This digital write high, and we execute this code. We put the delay, and we digital write low to everything and execute that code. But for that, all the lights would turn on, and then all the lights would turn off. We want to do something a bit more than that. We want to conditionally turn some lights on and conditionally turn some lights off. So let's first ignore this piece of code here. Okay, let me just Control X. So this here is what I'm talking about. With this loop, the same for I is equal to 0. Right? So the reason we do this is because I wanted to access it, right? But we'll talk about why we use this particular 8 and 0 here instead of 1 and 9 like before. Okay, okay, good. Now, this here, this loop is going to turn everything on. It's going to delay. Then it's going to turn everything off, right? Digital write, the for loop. The same concept as about here. Now, we don't want to turn everything on, right? We want a different thing. We want this. We want if the ASCII value, right, is true, then write high. If the ASCII value is not high or is not true, it's low, then write low, right? Digital write high if it's true, digital write low if it's not true. Now, generally, for if-else statements, we would do something like if A is less than B, right? If A is less than B, right? Execute some code, right? Execute that code. If that else, right? Else, execute some more code, right? And we do that. But inside here is an ASCII value, from the variable ASCII n, which is a Boolean value, which is either true or false. So when we do A is less than n, so if we do something like bool my variable, whatever your variable name, is equal to A less than n, what this is going to do is going to evaluate this expression. Is A less than n? If A is 1 and n is 5, and A is less than n, then it's going to put true in this variable. It's going to be like writing var equal to true. So in here, we can just put the variable name. And that's what we did here. We put, where am I? We put if ASCII n is true, then do digital write, else digital write low, right? Good. Now, the reason we use for I equals 0, I less than 8, I plus plus is because when we're accessing parts of the array, so from MATLAB, again, you guys would remember that you would have some x is equal to some square bracket 1 space 2 or 1 comma 2 comma 3 comma 4, right? And this is your array. And if you wanted to refer to the second element, you'd have to do x parentheses 2, and this would pull 2 out. Let's say 2 was some number like 10. What this would do in MATLAB is it would access the second variable, right? It would access that second variable, and we know the value of the second variable is 10, right? It would access 10, right? That's what would show up. That's what would show up on your output for MATLAB, right? Now, in C, what we do, let's say we have that same ASCII variable, ASCII n square bracket, instead of parentheses, square bracket, right? And in C, instead of these square brackets here, we use curly brackets. So now these little things like the curly brackets, square brackets, you're going to pick up over time. And the more code you write, you're going to get used to them, right? Okay, good. So what we do is ASCII and square bracket. And let's say the first variable is, okay, variable 1, 2, 3, 4. In C, if we say 0, that refers to the first variable, right? This is equal to 1. If we say ASCII n 1, this refers to the second variable. So it's 0 index. So 0 refers to the first variable and 1 refers to the second variable. So if this has 8 elements, right? 5, 6, 7, 8. The 8th element is actually ASCII 7, right? Because 0 counts as the first one, okay? So for that reason, we do this so that we can access here. So this is going to change from 0 to 1 to 2 to 3. And that refers to the first, second, third, fourth variable. But remember, it starts from 0. So that's why we start I equals 0 here, right? And then we just do less than 8, right? So 7 is less than 8, 8 is not less than 8, and then we increment and we go about our way, right? And of course, digital right, because the pin numbers, we did pins. We did pin from 1 to 8. So for the pin number, we actually want 0 plus 1, which is 1, right? We don't want 0 because we're not using pin 0, right? We're using pin 1. So that's why we do I plus 1 here, right? Good. Now, any questions? If you had to write this code for yourself, do you think you could be able to do it? Yes or no?
Sir, with some guidance, yes, but for
With
the
some
most,
guidance. All right, good. So that's the point. So today's class is going to be a tutorials class, right? And I want all of you to try and make this circuit. And as you get issues, you can share your screen and I can guide you through them, right? But I want to make sure that everyone is able to build a simple circuit and execute some code, right? So first things first, everyone just Google search a binary ASCII table and find what's the binary for your name, right? What's the ASCII for your name, and write it down. And then open up Tinkercad and start drag some LEDs out, right? So everyone do that. And as we run into issues, let me know, okay? Anyone that hasn't gotten the blink circuit to work yet, let me know and you can share your screen and I can guide you through setting up the blink circuit as well. All right, good. So let's start working. Let's make this a tutorial because you guys need to at least be able to build one circuit. All right. Does someone want to share their screen while they're doing it? Let me start the simulation so you can see how mine works. So you see here, 0, 1, 0, 0, 1, 1, 1, 0. Essentially how it works. 0, 1, 0, 0, 1, 1, 1, 0. And that's it. That's all I want you to do. So find a letter for your name. And start building the circuit. I see. Okay, if you guys can see here, you can just pull the ASCII for your name. You can do capital or common, whichever one you want to do. Right, and let's start writing this code.
Excuse me, sir. Sir?
Yep.
Sir.
Yeah.
Yeah, sorry, sir. Could you just go back to the slide where it shows the Arduino board again?
Okay, sure.
Just want to take another look at it.
Okay, this one?
Yeah.
Yeah,
Okay,
so
thanks. That's all I needed.
yeah, so remember it's building off the Blink program, right? So the Blink program was one LED, right? One LED ground to one pin, whichever pin you specified. Now this one is multiple LEDs, right?
Right.
Yeah.
Yeah.
It starts out there. Yeah. And you can share your screen while you're setting up and stuff so other people can follow along if they're not getting through. Right? But any questions, just let me know, type in the chat or just turn your mic on and ask. Right? All right. Okay. So how far are you guys? Finish at least connecting on the circuits, or did you start on the code first? Which part you start on first?
So just done connect up the circuit. Now writing the code.
Okay, good. If you get in trouble, again, let me know, right? Anyone else finish connecting on the circuit, or did they start on the code first? If you want, you can just share your screen and let me look at your code, correct any mistakes. Look at your circuit, correct any mistakes there as well. Okay, any progress? No.
I'm getting some code errors, sir. I'm trying to fix that before I show anything. Or
Just share your screen and we can fix it together. All right. What about the odd people? Angeli, Antonio, Colin, Dominic, Michael, Siad, where everyone else at. So share, go ahead and share your screen, Vlad.
I can see my screen.
Okay, good. All right, circuit looks good. 1, 2, 8. Scroll up all the way to the top. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. Okay, let's get scroll on to the loop part now. Okay. Okay, so the if ASCII V in the if bracket needs to have I in it. Because we're referring to particular elements in the array, right? So I is going to be 0. So the 0th element or the first element in the array. So we need to put I inside those square brackets. Okay, good. They shall write I plus 1, else they shall write I plus 1 low. Okay, scroll down. Okay, that's good. Try compiling it. Yeah, there's a blank.
All I was missing was the I.
Yep.
Thank you, sir.
Yeah, that's what I said. Share your screen and so verify the numbers are right. I see. That's why I told you guys share your screen if you're having any issues, and we can fix it together. Because it might be something simple and you just need a fresh pair of eyes. What about everyone else? Is Vlad the only one doing this exercise? Michael, are you finished? Where are you?
Sorry.
Yeah, well then what
This
do you
is
think?
Felix speaking.
Yeah, what do you think?
Sir, how you rotating this? Yes, I'm saying, I'm asking,
How do you
how you
rotate it?
rotating this Arduino board?
Rotate
The
it.
Arduino
So
board.
you click on it. You click on it, and then to the top left-hand corner, you see these triangles here. These triangles there, right? So you click on the
Yes,
board,
sir.
then you click the triangle thing, and it rotates. You like that?
Thank you, sir.
Good. Anyone else? I'm gonna give an assignment maybe later this week, so I want to make sure you guys can, program these boards so you don't have trouble in the assignment.
Sure. Sure.
Oh yeah, someone speaking.
Yes, sir. Sir. Sir, the last part for the circuit. I'm still working on the circuit.
Could you please give
So
me
how
a
is?
second? I'm on the phone. All right,
All right. No
just
problem.
1 second. Yeah, I'm sorry, but I was on the phone for a little bit. Yeah, well then, go ahead.
Now I just wanted you to check my circuit.
Yeah, go ahead, share your screen, and I'll check it. Okay. Okay. All right. You can zoom in. So to zoom in, you use your 2 fingers on the mouse pad and zoom in like a phone. Okay, good. I got 1 to LED, 2 LED, 3, 4, 5, 6, 7, 8. Good to ground. Okay, good. Now move over to the code. Okay, good. So void setup in mode 13 output. Okay, just on top of void setup, do int I. So go to void setup above it. Like go to the first part of the text document, like, and press enter, and then right on top of void setup. All right, good. Then right on top of that, do int I, int, t. int space I, good, semicolon, semicolon. Good. Now go in back to void setup, right? And we're going to create the for loop. So inside the curly brackets, the curly ones, right? Press enter right there. Good. Now start typing for open parentheses, close parentheses, open and close parentheses, parentheses, not brackets, right? The regular brackets, like the ones above 9 and 0, those ones. Yeah, good. And now inside that, right, I equals 0, semicolon. You can put a space if you want. I less than 9. 9, semicolon, I plus plus. Plus plus. Okay, good. Now put curly brackets, come out the parentheses and put curly brackets the same way void setup is set. So put curly brackets now. Just type 2 curly brackets. 2 curly brackets, yeah. The close one, good. And put pin mode 13 inside that. Copy pin mode 13 and paste it inside those 2 curly brackets. The entire line, yeah. Good. Just cut it and paste it. Yeah, cut it and paste it. Great. Very good. Now change 13 to I. Yeah, I, good. Now do the same thing with digital, right? Copy back the same loop and put it in the void loop for the, so this is void setup on top. At the bottom, that is void loop. So copy the same loop and put it back at the bottom in void loop for digital, right? Okay. Yeah. So just press enter, paste that. Good. Now remove pin mode and put digital right now. From inside the curly brackets, remove pin mode and put digital right instead, right? No, you can copy and paste the digital right command from below. Cut and paste. Yeah, so you see at line 15, you can just cut this digital right line and paste it inside the curly bracket. Yeah. Yeah. You need to change output to high, right? High. Capital. Do capital. Capital HIGH. Okay, now delete this, delete line 15 you have there. That little thing you have left back in line 15. So come down 2 lines. Yeah, line good. Okay, good. Now do the same thing for digital right low. So you paste back the same for loop with digital right low inside after the delay. Yes, but you want to put it after the delay, right? Because we want to turn all 9 on, then we want to delay, then we want to turn all 9 off, right? Yeah, so you have to put it underneath delay, right? So it's going to be 4 digital right high, then it's going to be delay, then it's going to be 4 digital right low, then it's going to be the odd delay, right? You get that? So the delay on line 18 needs to be in between those two for loops. Yeah, good. Paste it right there. You can press enter to make some space. Right, good. Now change the digital right high to low in the second one. That there to low. Good, and you can delete line 21. Okay, good. Now you can backspace up to remove some of the space. Yeah, good. Now run that. What this is going to do is going to turn all 8 lights on and turn all 8 lights off. So run that. See, turn all 8 lights on and then turn all 8 lights off. Okay. One of them isn't turning on. Which one is that? Zoom into the lights. Let me see. Number 2 is number 2 not connected to the wire. So number 2 isn't connected, right? So you gotta stop simulating, then delete the wire and draw it back, right? Good, now draw one from yellow. Okay, good. Now simulate it again. Just press escape, right? Good. Simulate it again. Good, now all 8 are lighting, right? So this thing at the side, you can, with wiring components, you can just close that off. So now what you need to do is the conditional statements with the ASCII, right? So you got to find the ASCII for your name, which is while-in, which is a W, and then you set up a variable, right? So you can stop sharing your screen and I'll share my code and you can look at how the conditional statements with the ASCII is set up, right? So you can go ahead and stop sharing. And let me share mine. Okay, good. So here at the top here is the ASCII for my name, N, right? So you come to the ASCII table, you find W, which is while-in, which is 0, 1, 0, 1, 0, 1, 1, 1, right? 3 ones. And then you put that in, right? You put that in as false, true, false, false, true, 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 false, or whatever the 1s and 0 is for you, right? You set that up, set that variable up. Then you just inside your for loop for your digital right high, you're gonna input this code here, right? And this here is the same delay digital right low from before, right? So you have that piece here, but it's just, we don't want to turn on all the lights. No, we only want to turn on some of the lights. So that's why we have this conditional statement here, right? Good, so try and implement this. Remember, you need to do this first at the top here, and then you come back into your loop and you do this, the conditional, right?
Yes, sir.
The true, okay, good. So do that.
I'll work on it.
Good. All right. I trust everyone else is getting through, right? Because when I give you the assignment, everyone should be able to do it. If you guys want, I can send you this code. So maybe if you don't get it out in this class, you can try on your own time and figure it out. So I'll send you this code. Right. And yeah, and I'll send you a picture of the circuit so you can look at it as well. Okay. Anyone else having an issue that they want me to help them sort out?
No, sir. I'm at the same point as well. Then. Just follow the steps and work on creating the ASCII code.
Okay, good. All right, so we'll just go until 2 o'clock, then we'll cut off, and I'll send you guys the code so you can continue working on it on your own. Right. And this, of course, you know the circuit diagram. The circuit diagram is simple. All right, so I think we can call it a day there. I'll email you guys the code and a screenshot of my circuit so you can work on it on your own. All right. Did you guys decide on a time for the next class? If it's going to be Monday or Thursday?
Sir, what time on Thursday would you have free?
Free. Suggest some times and I can tell you guys back if it's free. Right, just send me some times via email and I can tell you which one's free. Right, I don't know right now off the top of my head. I'll have to check. Okay.
All right. So we have to cater for 2 hours, right? Or 1?
Yeah, 2 hours, 1 hour. It depends. Let's cater for 2.
Okay. I'll get back to you.